Today what we're going to do is we're going to look at chapter 12 and start section 3, section 3a today. If I take a look at this figure, this is a pyramid, and most of us know of pyramids as being in Egypt. And so some of the bases of pyramids can be triangles, some can be squares, some can be rectangles, some can be a pentagon. This particular shape, you're going to notice that the base is what it's sitting on, and that is a rectangle. And we talk about a base edge. The base edge would be what I highlighted. So it's that orange piece. The edge is just the outside of that shape, and then the base would be considered everything inside that shape also. Looking at the lateral face and the lateral edge, we've looked at that before. Remember, the lateral was like the middle. With pyramids, they don't have, a top and a bottom and a middle. They actually just have the triangles. So the triangles are what makes the lateral face, and you're going to notice in this figure there are 4 of them. And when we talk about the lateral edge, that is the outside of that triangle. So it's this red part that I'm highlighting here. Moving on, when they talk about a vertex, there's several. There's 1, 2, 3, 4, 5 vertices. It's where the edges come together. And then finally, probably the most important are the height and the slant height. When we talk about the height of a pyramid, what we're talking about is it's going from the tippy top of the pyramid, coming straight down, and it would form a right angle. So it's almost like it's suspended from the top of the pyramid. When we talk about a slant height, what that is I'm taking a look at the side of the shape, the triangles, and it is the height that comes down off of that triangle. So in other words, I take the lateral face, and the slant height is the height of that triangle. And you can see that the triangle's kind of slanted, so that makes sense that it would be called the slant height. Now let's keep going and talk a little bit about how you find the surface area of the pyramid. Well, what you do is you find the area of the base, and then you add together the area of the lateral faces. Okay, if you'll notice, underneath that there is a net of a square pyramid. Again, square, they told us the base is a square. And then you're going to notice that the lateral faces are those triangles, and in the middle of those triangles is a dotted green line. That dotted green line, those are the slant heights. And those are what you're going to use to find the area of the triangles. And you'll notice it kind of looks like a flower. And each triangle comes off each side of the shape of the base. Let's take a look at this word problem. We're going to find the surface area of a pyramid with hexagonal base, and each base edge is 60 meters long, and it has a slant height of 35 meters. So an example would be, and I'm going to draw a picture because I think once you see the picture, it makes a little bit more sense. Here is your hexagon, and the base length, or the base edge, is 60 meters long. Okay, and it's a regular pentagon or hexagon, so that would be true of all the sides. And then off each one of those is a triangle that eventually forms the pyramid. When we find the area of the slant height, or the area of the triangle, they're going to give you that slant height. And you'll notice over here it says the slant height of 35 meters. So if I come over here, this is 35 meters. And that is just the height of that triangle. So now let's go ahead and let's look at the surface area of this figure. The first thing that I'm going to do is I'm going to look at the base, which of course is the hexagon. So area equals 1/2 AP. Area equals 1/2. I do not have the area of the base. So I'm going to go ahead and I'm going to do a little review. If you remember, we took these and we put in the center of the circle or center of the hexagon. We drew in the radiuses. So I ended up with 6 triangles. So I take 360, I divide it by 6, which gives me 36. Then I take the 36 and I divide it by 2 to get me, oops, I'm sorry, it's 60, not 36. 60 to get 30. Okay, and so what essentially I'm doing is this base is 30, and I'm going to cut this triangle like this. So now I'm looking at just this triangle, and this becomes 30, this becomes 60. The base, the bottom of this also becomes 30, and the reason is if the whole bottom of this right here is 60, well, I'm going to divide it by 2 to get my 30. Okay, so I'm going to come down here, I'm going to blow up that triangle. This is 30, this is 60, this is 30. Again, I'm going to grab my x, 2x, x root 3. So if x is 30, then my apothem is 30 root 3. So now that I have my apothem, I'm going to go ahead and I'm going to fill that in. This is 30 root 3. To find the perimeter, I'm going to take 60, which is one of the sides, and I'm going to multiply it by 6 because there are 6 sides to a hexagon. And when I multiply that through, I get 5,400 root 3. Now you could bring it all the way through, but I'm going to leave it as root 3 so I don't have to chop off a number. So that is the base of the figure. I got to label that. Okay. Now I'm going to take a look at the lateral area. So the lateral area, there are 6 triangles. The formula is A equals 1/2 base times height. Okay. I know that the base of the triangle is going to be 60 because remember this spot right here, they said the edge was 60. So I'm going to go ahead and I'm going to put 60 as my base, and then they tell me that the slant height is 35. So I'm going to go ahead and I'm going to put in 35. One of my lateral areas is 1,500. So to work on the total surface area, I'm going to take the base, which is 5,400 root 3. I'm going to add 6 of these because they are the triangle and there's 6 of them. And so the total surface area when I bring it through my calculator is 15,653.1 meters squared. So it was a nice review of how do you find the area of a hexagon. Let's move on and take a look at the Great Pyramid of Giza. It was built in 2580 BC, and they're saying that the height of it is 481. So when they're talking about this height, and let me highlight it, this height right here, what they're talking about is that is coming from straight at the top, coming straight down, forms that right angle, and that's 481. And they say the edge of the square base is 756. So what they're saying is this right here, is this piece right here, and it is 756. So what they want you to find is they want you to find the lateral area to the nearest whole number. So they don't really care about the base. All they're caring about is the triangles. And they want you to find the area. Well, our problem with this is to be able to find one of the triangles. So we'll do lateral area, and there's going to be 4 of them. Area equals 1/2 base times height. Area equals 1/2. My base is 756 because that's what they gave me, but I don't have the slant height. So what you're going to do on this to find this measurement, you're going to create a right triangle. So you've got that bottom part there. To get that, you take 756 and you divide it by 2. And when you do that, you get 378. So this is 378. And then what I need to find is I need to find that slant height. And you'll notice that it creates a right triangle. So I'm going to kind of shade it in here. It's almost like a slice, a side section of the piece that is being taken out of this figure. Okay, and so this is called the slant height. So to find the slant height, what we're going to do is we're going to take 481 squared plus 378 squared, and that's going to give me the slant height squared. So let's go ahead and let's bring those numbers through. So I get 231,361 plus 142,884 equals the slant height squared, which is 374,245 equals the slant height squared. And then we're going to square root both sides. So the slant height is 611.76. So what we're going to do then is we're going to take this slant height that I have right here, and I'm going to put it as my height of my figure. So that's 611.76. Area equals 231,245.28. That is one of the sides. So to find the total lateral area, you're going to take 4 times that. So the total lateral area is 924,981.12, and the label would be, they didn't give us a label, so we'll just go units squared. So the reason why this problem is important is they asked you for the lateral area. They didn't ask you for the total area. So kind of keeping that in mind when we're doing this. Let's go ahead and go down to the final problem. This asked me to find the total surface area of a square pyramid. So I know that it's a square. And so I'm going to look at my base. My base is a square, so area equals base times height. Area equals, okay, I don't have that, but I can find it. I know that if this is 3, then I know that the base of this is going to be 3 plus 3, which is 6. So the base of this is 6. My height is 6. So I end up with 36 for the area of the base. Now what I'm going to do is I'm going to go ahead and look at the lateral area. And there are 4 of them. So area equals 1/2 base times height. Area equals 1/2. Now my base is going to be 6, and I know that because of what I did up here, okay? Because if it's the side of the square, it's going to be the side of the triangle. But now I need to find the slant height, okay? So we'll call this H. That's the slant height. And you'll notice that the height is 7, and you'll notice that the base is 3. So I'm going to go ahead and I'm going to use the Pythagorean theorem for this. Square root both sides. H gives me the square root of 58. And you can put that in a decimal if you want to. I tend to leave it find it's a little bit easier. So this is the square root of 58. So the area would be 3 root 58. So 1/2 times 6 is 3, and then you just leave the 58. So now what I'm going to do is I'm going to go back and say, okay, the total surface area, I have the base, plus I'm going to take 4 times the lateral area. And when I do that, I end up with 127, and it would be units squared. And I stopped at 127 because if you look at the problem, it says to the nearest whole number. Otherwise, they tell you how to round. That is it. That is pyramids in a nutshell. If you have questions, please let me know. Otherwise, we'll talk to you soon.